Hey everybody. All right, so let's get started. I'm going to start, 1 through 4. All right, so Nathan, you want to quiet down, please, so we can get going here? All right, sorry, I had to put that in. And a shout out to the two knuckleheads who wanted me to say shout out to them. All right, 1 through 4, it's just 4 questions, all right? So you should be able to answer that. I'm not going to answer those. You can look them up. Those are just definitions. You know what? Let me read them off real quick. Array that divides a two congruent angle bisector, two lines that intersect to form right angle perpendicular. 3 is net. Some of the complementary is number 4. All right, easy enough. All right, so for number 5, it's giving you, I don't know if you guys can see it. All right, that picture up top with the numbers. All right, so you have to figure out if you fold that back into a box, all right, what are the opposite sides? So the best way to do this, if you can't picture it in your head, then what you want to do is actually make it like what Gianna did. See, there's a shout out. All right, so what you want to do is actually make it with a piece of paper and then just label the numbers there and then fold it where the lines are. All right, and what you'll see is, if you look at the number, 1 and 3 will be on opposite sides, 5 and 6 will be on opposite sides, and 2 and 4 will be on opposite sides. Okay? All right, so, all right, make an orthographic drawing. Number 6 for the isometric, so you have to make the front, top, and side. Okay, so I'll just try to do this real quick. That's too, I realized I started too high. This is all rough. Remember, think parallel lines if you make these. Okay, so here we go. The top, all right, everything that's top, this is the top view. And remember, top view, you're looking down. Okay, so that's all the top view. So once you get it, it's just like this. All right, it's going to look something like, I've left out one thing. You figure out what I left out? This right about there. All right, the L section is right here. This part right here is that. So 1, 2, 3, 1, 2, 3. Okay? All right, the side is looking at this right here, this part, and this part. All right, so it's going to look something like this. All right, just a rough estimate. All right, so 1, 2, I should say 4, so it's not to confuse it. 5, 6, 4, 5, 6. And the front view. And remember, this part is hidden in the back. So 7, 8, 9. And so we have this. All right, so right here. This is 8, 7, and 9. You got to, this is, if you look on the picture, it only goes up 1, and here this part goes up 2. So you got to draw roughly somewhere around there. All right, and this part is this part here, this part here. Oh, and it goes across like that because of this line. All right, so this is actually 9, but this whole thing is 7. Remember, this little part here, you see the dotted lines? It's behind it. This is behind it. Okay? All right. Don't forget, you can, oh, I should probably hit pause on this part so you don't have to watch me do this. Yeah, let me hit pause. Ta-da! Magic. All right, so the D here, this is number 7, 8, 9. All right, D is actually behind the box, right? So imagine a cube. So something like this. This part right here, this is D. All right, it's behind it. All right. All right, so number 7, it says, name 2 intersecting lines. All right, well, technically, we're actually not looking at lines. We're looking at line segments, right? All right, but if we look at 2 intersecting ones, all right, RB and AB, CB and AB, CB and RB. All right, anytime you see like an angle here, that's your 2 lines are intersecting. Intersecting doesn't have to mean going through, all right? They're just intersecting here, so they intersect there. All right, so every corner is an intersection. DC, AD, TD, QA, QR, QA, and TQ, TQ, and QR. All right, so those are, so basically every place there's an angle or the corner, every corner. Name the intersection of planes QRBA, QRBA. So the front of the box, so front of the cube, and TSRQ, TSRQ. So this plane and this plane. So if you have, I should have had the box here. All right, so a box like this. So if we get something like this, it's actually to this plane and the top here. All right, so this line is where they intersect. So this line is where they intersect. QR. Name 3 non-collinear points. Remember, think of what non-collinear. Co means together. Linear line, L-I-N-E-R. Linear line. All right, co together. So here's 2 collinear points. There's 2. And there's none of these, there's not 3. So if you label any 3 points, those are 3 non-collinear points. And everywhere here, all the points that they show, only 2 are collinear. So you mention any 3 points, it's non-collinear. RTD, CAT. Oh, I have a cat. All right, so any 3 points you mentioned, they're non-collinear. All right, any 3. In this case, right? It's because they're only mentioning 2. Now, if I put another point here because I want to, all right, then you would have 3 collinear points. Because remember, on a line, it has infinite number of points. All right, determine whether a statement is true or false. 2 points are always collinear. Yes, right? Because if I do any 2 points, I can always make a line connecting them. All right, doesn't matter where they are. All right, so 2 points are always collinear. LM and NL are the same ray. All right, so remember the arrow makes a difference. Which letter we're talking about makes a difference. All right, so it's saying here's a point, we'll call that L. Here's another point, M. So this is LM. This, all right, this is ray. That's ray NL. The first letter, remember, shows you which point you start at. And this is ML. Remember, the ray up here doesn't indicate direction. It only indicates what it is you're talking about. All right, so really what you have is this right here. And when you tell somebody this, what you're telling them is, I want you to start here and go forever that way. That's what you're telling them. And when you write it the other way, what you're really telling them is, I want you to start here and then go that way. All right, so the first letter makes a difference. Even though it's on the same line, the first letter lets you know, lets the people know what direction you want them to pay attention to. All right, so that was 11. All right, pause. All right, by the way, I'm in my kitchen. You can see my fridge. Bunch of stuff I put on my fridge. All right. All right, so here it's asking, find 2 possible coordinates of... Find 2 possible coordinates of Q such that PQ is equal to 5. Okay, so... you got to think past what they're talking about, all right? PQ equals 5. So, find 2 possible coordinates of Q. All right, so one coordinate of Q, they've labeled as H. All right, so 1, 2, remember this distance, all right, the distance, PQ is basically the distance from P to Q. All right, so it's 5. It's 5 units away. Remember, the negative sign is only an indicator from to 0, but this means just how many units away from your starting point. So it's 1, 2, 3, 4, 5. So right there, H is 1. But the other way is going the other way, which they don't make the number line long enough. They want you to think that, though. 1, 2, 5, 6, 1, 2, 3, 4, 5. 4, 5, 6, 7, negative 7. So that's the other place for Q. 5 units away that way, 5 units away this way. But I think they might be trying to trick you that Q is H. All right. Or it's probably, oh no, it's for number 13. That's why they labeled it H. All right, use the number line above. Find the coordinate of the midpoint of H. So midpoint, remember, it's the middle point. So midpoint is halfway. So if this has a total distance of 5, all right, what's halfway? 2.5, right? So 2.5. So we go 1, 2, and then half. Here, 1, 2, and then half. All right, but you can always do that use the midpoint formula. All right. 3 minus 2 divided by 2 is 3. All right, so it comes to, all right, which is 0.5. All right. Okay, find the value. All right, we gotta hit pause, sorry. All right, so we're up to number 14. All right, so do we know that B is a midpoint, right? Yes, we do know, because remember, when you see the little dashes like that, it means this length is equal to this length. Because remember, the same thing with angles. If we see one there, all right, or two there, every time you see it, it means the same length. Okay, so we know that the length of AB is equal to the length of BC. So you just set them equal. It's asking you for the value of them. So it's basically, it's just 3m plus 5 equals 4m minus 10. Now at this point, it doesn't matter which side you go to, but it's easiest to try to put m over here because 4 is bigger than 3. All right, so subtract 3. If you know this already, I'm just doing it for those who have a little trouble. All right, so 0 and then 1m, which is just m. All right, so we have m minus 10 is equal to 5. All right, then just add 10 to both sides. M equals 15. All right. All right. So here we know that x, y, and y, z are not equal because x, y has a value of a and y, z has a value of a plus 8. All right. We don't know if that, I mean, if a is 8, that means that's double, right? But we don't know what a is at all. But we know that the distance from here to here is 50. All right. So then it's just a matter of a plus 8. So it's this length plus that length is equal to 50. All right. So a plus a is what? 2a, right? So 2a plus 8. I mean, if you have any trouble with that, why it's 2a, just think of 2 plus 2 is equal to 4, right? So it's the same thing as 2 times 2. All right, 3 plus 3 is equal to 6, which is really just 2 times 3. All right, so when you add two of the same numbers, it's 2 times that number. All right, this is just a reminder if some of you forgot the simple stuff, okay? Equals 50. So you subtract 8. All right, so 2a equals 42. Quick, what is it? Come on, Gabe. All right, so a, divide both sides by 2 equals 21. All right. All right, that was number 15. Halfway done. All right, so 16, obviously this angle. All right, it's acute. I'm not going to draw this stupid picture again. All right, 17. All right, because remember it has this. All right, it's a right angle or 90 degrees. Make sure it's on. Okay, it's on. All right, these are. All right, so really doesn't matter how you draw it. It's not really important. You don't have to be accurate with this because it's just trying to, well, let's see what it's asking. N, M, P, R. All right, so what do we know? All right, we know that N, or this angle, angle NQM and angle PQR, they're congruent, equal, all right, because they're letting us know they're equal. And so we know also NQM and angle MQP, they're adjacent, but so is MQP and PQR, they're also adjacent. We don't know anything else just based on the picture. Now, so this is where we have to start looking. So remember, the little m here means measure, means like the degrees, how much it's worth. Okay, MQR. And we know, though, this whole thing is great. Well, I should say it looks greater than 90, but it's less than 180. So this whole thing, it looks obtuse, right? And that's equal to, how much? 61 MQR. So it's saying that this is 61 degrees. All right, that's the measure, that part. All right, and MQP is equal to 25. So MQP, all right, so give me another color. Pick a color. That's not the one I was thinking. All right, so MQP, that right there, that's almost the same, 25. All right, so what are they asking? PQR, so PQR. So basically it's just measure of MQP plus the measure of angle PQR is equal to the measure of angle MQR. Right? This angle plus this angle equals that angle. All right, so here we go. MQP, which is 25, plus PQR, which that's what they're asking us for, angle measure PQR is equal to that whole thing, which is 61. So it's really 25 plus what number is 61. That's all it's really asking. All right, but we could do it the long way. 25, which is equal to 30. I better get this right. 36. All right, 36, right? Yes. Okay. All right, so that means that the measure, so this angle right here is 36 degrees. Capiche? Entiende? All right, I don't know the Portuguese version. Sorry. All right, let me erase. All right, so we're doing 20 to 23. All right, I drew this ray out here like this just to remind you that the ray length has nothing to do with the angle itself. I could have drew the ray like that short, doesn't matter. All right, so I just put that out there just a reminder. Don't get thrown off by the length of a ray when you're trying to focus on angles. All right, it's an easy way to get distracted. So the complementary angles, what do they have to add up to? 90, right? So we know angle, remember here's our 90 degrees right there. So angle, the measure of angle AD, that's a D, ADB and BDC, they're complementary. All right, are there any other complementary? No. This is 90, that's 90, that's 90. These are 90, but it's not complementary with anything because they have to add up to 90. Two angles have to add up to 90. So these are the only two that add up to 90. This one already is 90. All right, so supplementary angles. So it's when two angles add up to 180. So we know that CDF and FDE adds up to 180. And FDE and EDA, that adds up to 180. All right, those are the two. Now remember, it's two angles add up to 180. So these three do add up to 180. This one, and that one. But because supplements have to do with two. All right, vertical angles. Well, remember, the whole idea of vertical angles, you're just drawing intersecting lines. And if that's our point, this ray, starting from the origin, this intersection point, that ray and that ray, they're opposite rays. All right, this ray and this ray, they're opposite rays. So when two lines intersect, they're forming opposite rays at the intersection. So that means that and that are vertical, and that are vertical. So 2 is vertical, and 1, the two ones are vertical with each other. So on here, we could say this angle and this ADE and CDF, they're vertical angles. But these are two separate angles. So this is 90, and if, oh, okay, yeah. So EDF and ADC, that's, those two angles are vertical. All right, but we have to remember when we say ADC, we have to think as if this ray, DB, doesn't exist. All right, so you have to try to throw it away. All right, so the next one, give me a second. All right, so we're on, where are we? 23, almost done. All right, so remember, we're dealing with, you're dealing with adjacent angles where their non-common sides are opposite rays. All right, so here, two adjacent angles, but now that going that way, and so they share this ray, right? So angle 1 and 2 are adjacent, and they're sharing this ray, but they're not sharing these two. All right, that's what a linear pair is. When you have two adjacent angles, and basically the rays they don't share are opposite rays. All right, so for instance, if we have this, right, this setup, these are adjacent angles, and they share this ray, but these two rays, they don't share, but they're also not opposite rays, so these are not linear pairs. All right, think linear, remember? Like collinear, right? It's they share points that share, put the same points together on a line, all right, collinear, all right, so linear pair, all right, linear pair, all right, it's basically, think of the word line. They're opposite their rays that they don't share have to form a line. These don't form a line. This forms a line. Remember, a line is just, it goes in both directions off forever, right? So it's sharing the line. So a linear pair, they share a line that goes off forever. That's how you want to think about it. They're sharing a line that goes off forever. So look at all and they have to be adjacent, remember, all right? So angle ADE and angle EDF, they're sharing this line. So it's a linear pair and they're adjacent. All right, ADB and CDB, they're adjacent, but they're not sharing a line. All right, so we could say angle ADC and FDC, they're adjacent, right? And they're also linear because they're sharing this line. All right, and CDF and FDE are sharing this line, and the rays are going in opposite directions. That's going that way, and that's going that way. All right, so that's what a linear pair is. So just think they're sharing a line. Collinear, it points on the same line. All right, so the name itself, so if you try to remember that the name itself is giving away the answer. All right, it's hinting at the answer. All right. All right, so here is 24 and 25. So what we know about 24, all right, that these two, we know that these two are supplementary because that's a line. So that means this angle, all right, that's going to add to 180. So it's just basically, if we call that angle 1 and that angle 2, angle 1 plus angle 2 is actually the measure, right? It's going to equal 180. So that means 3x plus 31, that should be a 1 in there, 31, plus 2x minus 6 equals 180. All right, so 3x, combine like terms, 3x plus 2x, 5x, 31 minus 6, 25, yes, 25. 25 equals 180. Hey. Subtract 25 from both sides. So we're left with 5x equals 155. All right, so that's easy math now at this point. Divide by 5. Divide by 5. X is equal to 31 degrees. Hey, look at that. So x is equal to 31. I'm not going to forget this time. All right. Oh, they only have to find the value of x. All right. So 31. Now, if you want to go back and actually figure out the measures, I just plug 31 in there. 2 times 31 is 62 plus minus 6. So I would make that 56 degrees. So 180 minus 56, and that's your other angle. All right. Do the same thing here, except this time this angle 1 and this angle 2 is going to equal 90. So it's the same exact process, except it's going to equal 90. All right, so 3x plus 4x minus 15 equals 90. So same thing, combine like terms. All right, 7x minus 15 equals 90. So 7x is equal to 75. Okay, so that's, what would that be? That's a little, it's between 10 and 11. So it's a little more than 10 and a half. All right, so x is approximately equal to, I'm going to say, let me see. If it was 77, that would be 11. If it was 73.5, that would be 10 and a half. So it's approximately 10.7. All right, so I don't know exactly what it is. So that means that roughly is 32 degrees. This is approximately 32 degrees. Remember, you can't go by what the picture looks like. All right, so there we go. Okay. All right, we're up to, where are we at? 26. All right, draw 73 degrees. All right, you just have to have a protractor. And that protractor, remember, the way you draw 73, you have to start off right here. Here's your angle. All right, your 0 point, so you just, some ray goes out there, and you just find 73 here, or